Welcome, class, to your academic onboarding explainer for the TPMOS version 6.00 environment. I'm absolutely thrilled to be your guide today as we leave legacy OS bloat in the dust for a pure, sovereign reality. Look, if you've ever felt like modern computing has basically become a tangled web of hidden states and totally unpredictable behaviors, well, you're in the exact right place. Today, we're going to rebuild your understanding of an operating system from the absolute ground up.
Here is the syllabus for today's masterclass. We'll be looking at the philosophy of pieces, how files act as absolute truth, the standardized ops pipeline, building in the theater, and finally, sovereign and advanced horizons.
Let's dive right into Module 1, the philosophy of pieces.
In version 6.00, we operate strictly on the true piece method. Absolutely everything, from a tiny clickable button to an entire simulated galaxy, is considered a self-contained piece. But how do we define its existence? Beyond its DNA file, we have the mirror. It's literally just a simple flat text file called state.txt. That file defines the exact current reality of a piece at any given moment. We rely on these flat text files to ensure total auditability, meaning we never have to trust transient invisible system memory ever again.
I really need you to memorize this core academic thesis. If it's not in a file, it's a lie. In TPMOs, geography is destiny. Transient memory simply does not exist, period. If a piece of data is not physically written down in a directory, the operating system literally cannot see it.
So, why are we so incredibly strict about this? Well, let me tell you about the legendary Mirror of Tomokazu anecdote. Early in development, an engineer tried to optimize the system. They kept a player character's health points in a temporary global variable instead of writing it straight to the state file. When the system crashed and rebooted during a stress test, the player had 0 HP. They were permanently dead despite being at full health just seconds before. This disaster brilliantly illustrates why we mandate the mirror. Storing data anywhere else is just a one-way ticket to catastrophic system failure.
Moving right along to Module 2, Files as Absolute Truth.
You have to fundamentally understand that we don't use complex back-end databases here. Our standard file system directories are the active, beating heart of the universe, which means you absolutely must abandon the old heavy brain module design. In legacy systems, you had a single manager trying to do it all, calculating physics, reading states, updating files, and rendering graphics. And what did that give us? Endless sync lag. Version 6.00 mandates the thin brain approach. Your manager module simply acts as a router now. It just pulls for input and delegates all the heavy lifting to standalone atomic programs called ops. Now, the reason this thin brain model is a game changer is because it prevents what we call the directory ghost. You know the directory ghost. It's when your UI caches data that doesn't actually exist in reality anymore, like a deleted folder that's somehow still showing up on your screen. To eliminate this, we enforce strict state-first polling. The UI only renders what the file system confirms is 100% true. We also enforce atomic file updates using the rename function, so data is never caught halfway through a write, and we mandate master ledger logging for perfect time travel debugging.
Let's get into Module 3, the standardized ops pipeline.
We need to break down exactly how user intent actually shifts reality in this OS. Every single interaction in TPMOS is a strict 4-step loop. Step 1 is the input, where a sensation like a keystroke gets recorded into a history text file. Step 2 is the brain. The thin brain module reads that file and routes the command. Step 3, the muscle, where a standalone op is executed to modify the state text file, our mirror. And finally, Step 4, the theater, where the parser detects the change and composes the new reality on screen. It's elegant, it's auditable, and it's beautifully simple.
But hey, as with all powerful systems, there are dangers. Let this be a warning. The disaster known as the pulse that broke the world. An engineer once accidentally wrote an infinite loop where an op triggered a render pulse, which re-triggered the module, which re-triggered the op. It created a massive feedback loop that completely melted the CPU. Because of that little incident, we now strictly enforce a 60 pulses per second cooldown. Safety first, class.
All right, Module 4, Building in the Theater.
This is where we transition from theory to practice and explore the actual developer toolkit you're going to use to forge interactive projects. When you create software here, remember, you aren't building monolithic apps anymore. You are following a precise 5-step project flow to forge a collection of ops. First, you define the piece's DNA. Second, you create the view markup. Third, you build the muscles. That's your standalone C code for actions like jump or save. Fourth, you register those ops in a manifest. And finally, you install the whole thing via Fondue, our centralized lifecycle authority that makes your new ops available to the entire operating system.
So how do you orchestrate all these different pieces without writing endless, repetitive C code? We use PAL, or Prisk Assembly Language. This is basically the assembly-style scripting glue that chains your standardized ops together into high-level workflows. But reflecting back on our earlier warnings, please always remember to bound your loops in PAL. We do not want to repeat the infamous assembly that assembled itself incident, where a script accidentally duplicated itself 10,000 times. To help you write all this, you're going to rely on two main tools every day. Op-Ed is your sovereign IDE for elegant universe manipulation. It gives you real-time visual scripting where you can literally drag and drop ops onto pieces. It's awesome. Meanwhile, FuzzOp is your chaos engine. It brutally stress tests your creations by just bombarding your ops with malicious data to ensure absolute stability before your code ever even touches the mainframe.
And finally, Module 5, Sovereign and Advanced Horizons.
Let's look at what this standardized ops architecture actually unlocks for the future. One of the most visually stunning advancements we have is CHT-MGL, or GLOS. This is our OpenGL shell. Through what we call the first dimension shift, GLOS proves that the piece method is totally scale-free. It literally takes your flat text-based 2D ASCII states and extrudes them into high-fidelity 3D voxel masks. And the absolute best part, it does all of this without you needing to rewrite a single op. The logic remains purely text-based, and the theater simply translates it into 3D. It's like magic, but it's just great architecture.
And this beautifully illustrates our commitment to exo-sovereignty. Spurred by that massive historical internet outage we refer to as the Great Disconnect, exo-sovereignty ensures that you are never, ever reliant on the cloud again. Through offline-first local storage, our P2P-net decentralized mesh topology, and an incorruptible shared ledger for consensus, your digital reality survives completely independently. Literally, even if centralized servers worldwide collapse entirely, your TPMOS nodes are going to keep the simulation running.
Then we have the AI brain. In this environment, AI is no longer just some static chatbot sitting in a window waiting for a prompt. It acts as a cognitive module. Using the Gemini 5 for context building, the AI can actually perceive your system's file states, and thanks to our tool-use architecture, it can independently execute standardized ops to actively manage and even debug the ecosystem. You're looking at an AI with actual hands on the keyboard.
Okay, now for the financial forge. This is where things get truly wild. Using the Yahoo project integration, you can engage in standardized arbitrage, meaning you can bind the very health, survival, or UI of your digital pieces directly to real-world stock market prices. Just imagine it, a digital pet that actually gets hungry if a certain tech stock crashes. The economic simulation becomes indistinguishable from the digital reality.
All of this standardization, the local files, the AI modules, the financial integrations, it all drives us toward one ultimate goal, the singularity node. We are aiming for a state where the operating system can autonomously repair its own code, earn its own funding on the market, and seamlessly collaborate with other nodes. Make no mistake, we are currently at step 6 of 10 on that incredible journey.
And that brings us to the end of our bootcamp. Now that you understand the language, the philosophy, and the strict standardized pipeline of this sovereign environment, you are absolutely ready to build. The future is unwritten, but whatever it ends up being, it's going to be mirrored in a flat text file. When absolute truth is just a directory away, what incredible reality will you forge next? Get out there, open your text editor, and start building. Class dismissed.